talk about how we can convert decimal numbers to octal numbers. Okay, so let's start with a simple number like 14. Yeah, let's start with 14. So this is the decimal number 14. Yeah, this is the decimal number 14 to the base 10. Okay, so what you have to do is, if you had watched my binary conversion, yeah, decimal to binary conversion, you would have seen that I divided the number by 2. Okay, here what you have to do is, you have to divide the number by 8, since octal number system is the base is 8. Okay, so if you divide it by 8, you will get 6. Okay, sorry, you will get 1. Okay, and the remainder will be 6. The answer will be 1 and the remainder will be 6. So you have to go from bottom to top approach. Okay, you have to follow the bottom to top approach. So 14 to the base 10 will be equals to 16 to the base 8. Okay, 16 to the base 8. This is what we have to do when we are converting from decimal to um, octal. Okay, now let's do another question. Okay, let's say we have 52. Okay, 52 to the base 10. 52 to the base 10. So if you divide it by 8, you will get 6 and the remainder will be 4. So the final answer will be 64 to the base 8. Okay, so you can say 52 to the base 10 is equals to 64 to the base 8. Okay, let's try something bigger. Okay, like 99. Okay, because 99 to the base 10 is special because we can't write 9 in the octal number system. We can't write 9 in the octal number system. It has to be 0 to 7. So let's try that. So if you divide it by 8, you will get 11. Okay, 11. Well, actually 12, right? Yeah, you will get 12. So 12 times 8 is equals to 96, which means the remainder is equals to 3. And you can continue dividing. So you can divide it again. So you'll get 1 and the remainder will be 4. So the final answer will be, okay, so 99 to the base 10 can be written down as 143 to the base 8. Okay, what about 255? Okay, so if you divide it by 8, 25, if you divide 25 by 8, you will get 3. If you divide 15 by 8, you will get 1, and the remainder will be 7. You can divide it again. So if you divide it again, you will get 3, and the remainder will be 7. So you are going from bottom to top. So the final answer will be 255 to the base 10 can be given as 377 to the base 8. Okay, what about a 4-digit number like 1023? 1023 to the base 10. What you have to do is, first of all, you have to divide it by 8. So if you divide it by 8, what do you get? You'll get 1, 22 means 2, 63 means 7. The remainder will be 7. You can divide it again. If you divide it again, you'll get 1 and then you have 47, so it will be 5. Remainder will be 7. You can divide it again. Okay, if you divide it again, you will get 1 and the remainder 7. So the answer will be 1777 to the base 8. So 1023 in the decimal number system can be written down as 1777 in the octal number system. Okay, so let's try another bigger number like 2048. So if you divide it by 8, what will you get? You'll get 2, 5, and 6. The remainder will be 0. And if you divide it again by 8, you'll get 32. The remainder will be 0. If you divide it again, you will get 4 and the remainder will be 0. Well, you can't divide 4 by 8. It will be again 4. So the answer will be directly you can say 4000 to the base 8. Which number? 2048 to the base 10. So this is how you have to convert from by the decimal to octal. Okay. What if we have to convert from octal to decimal? Okay. So as I said in the binary video, okay, we are going to use the abacus method. Yeah, we are going to use the abacus method. Let's say we have something like 52. Okay. So 52 in octal. So let's draw the abacus first. 52 to the base 8, we can draw the beats like this. We will have 2 beats here and 5 beats here. Okay, so we will have 5 beats here. Okay, so this the place value of this digit will be 8 to the power 0. And this one will be 8 to the power 1. Okay, so what you have to do is, you have to multiply by the place value, the beats. Okay, you have to multiply the number of bits by the place value of the digit. Okay, so here you have 2 and the place value is 1. Here we have 8. Okay, so what you have to do is, since you have 2 bits here, 2 into 1 will be equals to 2. Okay, here what does this 1 mean? Well, it means 2 into 8 to the power 0. Similarly, here we have 5 bits into 8 to the power 1. Yeah, because this is the place value of 8 to the power 1. So this will be equals to 5 into 8, which is equals to 40. So 2 plus 40 will be equals to 42 to the base 10. So 52 to the base 8 can be written down as 42 to the base 10. That's it. Very simple. Okay. So you can do this in multiple ways. Okay. You can do this in multiple ways as I explained earlier. For example, if you have something like 400 and we'll do 52 first. Okay. 52 to the base 8. What you have to do is you have to write it down. Okay. You have to directly you can say like here this the place value of digit 2 is 1, so I can write down 2 into 1 plus here the digit 5 holds the place value of 8 to the power 8 to the power 1, which is 8, so it will be 40. So it will be 5 into 8, which is equal to 40. Okay, 5 into 8, so that will be equal to 2 plus 40. So the final answer can be written down as 42. Okay, you can do it like this, or any other methods. That's also fine. Let's say if you have 52 to the power base 8, you will do 2 into 8 to the power 0, which is equal to 2. And then you will multiply 5 into 8 to the power 1, which is equal to 40. At the end, you will add all this and you will get 42. That's it. Okay. So any method is acceptable, but drawing abacus will take time and drawing these arrows will also take time. So try to do it directly. Try to do it directly. So let's try a question. Okay, let's say we have let's start simple, like 34 to the base 8. 34 to the base 8. How can we do this? Well, 4 has the place value of 1, so it will be 4 into 1 plus 3 into 8. So that will be 4 plus 24, which is equals to 28 to the base 10. Okay, so let's try a bigger question. Yeah, a bigger question, like 100 to the base 8. Well, this will be, since we have 0 here, don't have to multiply it by 1. Similarly, since we have 0 here, even if we multiply it by 8, the answer will be 0. Then we will have 64. Why? This is 8 to the power 2. Okay, so here we had 1, then we have 8 to the power 1, which is multiplied by 8. So 8 into 8 is equal to 64. So it will be 1 into 64. Why is it 1? Because the digit is 1. So the final answer will be 64 to the base 10. Okay, so this is how you have to do this. What about another question, like 377? Well, here 7 into 1, because that's the place value. And then here we have 7 into 8 plus 3 into 64. So we know 7 into 1 is equal to 7, 7 into 8 is equal to 56, and 3 into 64 is 192. So the final answer will be 255 to the base 10. Let me recheck this. 63, 255. Yeah, perfect. Now let's try another question. What about 1024 to the base 8? 1024 to the base 8. Well, here we have 4 into 1. Then we have 2 into 8. Then we have 0 into 64. Doesn't matter. And then we have 1 into 64 times 8 will be 512. So you have to write that down. 8 to the power 3, because you have to multiply this by 8 to the power 3. Okay, fine. So 4 into 1 will be 4, 2 into 8 will be 16, and 1 into 512 will be 512. So the final answer will be 532 to the base 10. Okay, let's do one final question. What about 2047 to the base 8? So this will be equal to 7 into 1 plus 4 into 8 plus 0 into 64 plus 2 into 512. So this will be equal to 7 plus 32 plus 1024. So the final answer will be 39 plus 1024, 1063 to the base 10. Yeah. So this is how you have to do. This is only about integers. What if we face decimals? in octal numbers? What if we face decimal in octal numbers? For example, 43.37. How can we do that? Well, it is also simple. Well, we know the abacus visualization. Okay, so let's draw the abacus first. So here we have the a to the power 0. So we will write down a to the power 1 here. But then from the right side, we will reduce the power by 1. So a to the power minus 1 and a to the power minus 2. So here we have 4 bits for a to the power 1. Let me draw that. And 3 bits for a to the power 0. Okay. And 3 bits for a to the power minus 1. And 7 bits for a to the power minus 2. So that's it. So a to the power 1 is equals to 8, a to the power 0 is equals to 1, a to the power minus 1 will be equals to 1 divided by 8, because we know in indices form a to the power minus 1 means 1 over a to the power 1. So this will be equals to 0 0.125. 0.125. Okay, so how can we do this? Well, if you divide 1000 by 8, you will get 125. So 1 over 8 will be dividing it by 1000. So 125 over 1000. So that will be equal to 0.125. So I'll write down the decimal so that we can do the questions easily. What about a to the power minus 2? You have to divide this by 8. So this will be 0.0152625. Yeah, this is getting too big. Yeah, this is getting too big. But this is why I gave just two decimals. Okay, so you just have to know how to do the question. That's the important part. Okay, that's the important part. 1, 2, so 1, okay, so 40, 5, okay, 5, 6, okay, 2, 2, okay, 40, yeah. So, but how to finalize the answer? Well, 8 plus 1 will be equals to, you have to add all these things, yeah. Well, you can't directly add. Why? We need to multiply it by the beats. So here you have four beats. So it will be 4 into 8, and this will be 3 into 1, and this will be 3 into 0.125, and we have 7 into 0.015625. And then finally, we have to add all these values. So that will be 32 plus 3 plus 0.375 plus 0. How can I find this? 7105, 1092, 10934, 109375, 109375. So if I add all this, I will get 35 plus I will get 0.384375. So the final answer will be 35.384375 to the base 10. So this in the decimal value, I mean the floating point value 43.37 to the base 8 can be written down as 35.384375 to the base 10. Okay, I know this looks a little bit confusing, but that's thing is simple. It's like what you did for binary. Okay, it's the same thing, finding the base value and multiplying it by the the value of the digit. That's it. Okay, now let's try another question. Okay, because practice is very important, or else we won't keep in touch with what we are studying. So I'll make sure we are doing a simple one, 52.72. Okay, so this can be written down as, well, we have 2 into 1 plus 5 into 8 plus, here we have 7. So 7 into 0.125. Okay, the place value of this guy is 0.125. What about the place value of 2? It is 0.015625. So plus 2 into 0.015625. So this will be equals to 2 plus 40 plus, and 7 into 125 will be 875, yeah, 184875, 0.875 plus 2 into 0.15625 will be 0. I'll get 0, 3 and 125. So this will be equals to 42 plus, I have 0.906, yeah, 90625. So let's recheck it, 0.875 plus 0.03125. So that will be equal to 0.90625. So the final answer will be 42 plus 0.90625. Okay, so this is what I can simplify it. Yeah, so let's say 42.90625. Okay, so that's it. So this is how you have to convert the floating point numbers in octal to a decimal number. Okay, so you may think, why am I not doing the floating point numbers in decimal system to binary or octal? You may think like that. I'm going to do a complete video on how you can convert the floating point numbers of decimal to directly the binary, octal, and the hexadecimal in a separate video. So stay tuned.
Thanks for watching the fourth video in our number system series. If you found this tutorial on converting between decimal and octal numbers helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master number systems and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.